Control systems. So before understanding the control systems, let us define a system first. So a system is nothing but it is a combination of components that are connected together to perform a desired task can be called as a system. So generally a system will be having input and as well as output. So this input can be called as the reference input and the output can be called as desired output. So whenever the number of elements or components that are connected together in a sequence to perform the specific function, then the group thus formed is called a system. Now what is the control system? Control system is nothing but whenever the output is controlled by varying the input. The output is controlled by varying the input. That system can be called as control systems. The output is controlled by varying the input. The output is controlled by varying the input. That system can be called as control systems. So here the collection of physical components that are connected together to serve an objective is called a physical system. So in the control system, if the physical components that are connected together to perform the desired task, that system can be called as the physical system. An idealized physical system can be called as physical model. Idealized physical system can be called as physical model. So for this physical model, if the physical model is represented with respect to mathematical equations, that can be called as mathematical model. Mathematical model. So here, to understand the control system, to analyze the control system, we are having two types of approach. First one is transfer function approach, and second one is state space approach. State space approach. So here, if the mathematical model is linear time invariant, if the mathematical model is linear and time invariant, linear and time invariant, called as LTI systems, then we will be approaching the transfer function approach. If the mathematical model is linear and time variant, then we'll go for state space approach. State space approach. So here, what is the meaning of linear time invariant and linear time variant systems? So if a system is said to be linear, if it obeys the principle of superposition, if it obeys the principle of superposition. So what is the meaning of principle of superposition? So for that we will take one system. So I am representing that system with H and giving an input x1 of t, and I have obtained an output y1 of t. So for the same system, I have given another input x2 of t and I obtained an output y2 of t. So now what I am doing is this x1 of t, if I am multiplying with a factor a and giving to the system in combination with x2 of t, which is multiplied with another factor b. So both systems I am giving to both inputs I am giving to the system H, then I need to get the output y3 of t, which is a combination of where we got, if I give x1 of t, I got y1 of t. If I give x2 of t, I will get y2 of t. If I am multiplying this multiplication factor a to the input, I need to get same multiplication factor at the output a into y1 of t plus here I have multiplied b to the x2 of t. So I need to get b into y2 of t. So if I am getting this kind of output when I am giving up inputs with respect to these multiplication factors, then the system is said to be linear, because as it is obeying the principle of superposition. So this is the principle of superposition. And what is the meaning of time invariant systems? So generally, if the system, if you are representing in a mathematical model, like by using differential equations, we are having differential equations in the mathematics. So when we are representing that system with respect to mathematical models, if the system differential equations coefficients which are describing the mathematical models are the functions of time, if the coefficients are varying with respect to time, if the coefficients are varying with respect to time, then that system can be called as time varying system. Time varying system. If the differential equation coefficients which are describing the mathematical models, are not changing with respect to time, or constant, then that kind of system can be called as time invariant systems. Time invariant systems. So here the transfer function approach, I will tell you what is the transfer function. In the transfer function approach, we are taking linear time invariant systems, which are nothing but mathematical models describing the physical systems. So here, with respect to this mathematical model, we are analyzing the transfer function approach for a physical system. So this is related to system, control system, and mathematical model of the control systems. And coming to the classification of the control systems. So generally we are having many classification of the control systems. So depending upon the presence of human being, depending upon the presence of human being, depending upon the presence of human being, presence of human being, control system is classified as manual control system and automatic control system. So if there is no need of human presence while controlling the output, that kind of system can be called as automatic control system. And if the man presence is needed, then the type of system can be called as manual control systems. And similarly, depending upon the presence of feedback, depending upon the presence of feedback, presence of feedback. What is the feedback? We'll explain later classes. This is open loop control system and closed loop control system or feedback control system. Feedback control system. With respect to feedback, there are two types of the control systems: open loop control system, closed loop control system, or feedback control system. And depending upon the hierarchy, the control systems are classified as, depending upon the hierarchy, open loop control system, closed loop control system, adaptive control system, optimal control system, learning control system. So depending upon the hierarchy, we are having 5 control systems: open loop control system, closed loop control system, adaptive control system, optimal control system, learning control system. And the fourth one, depending upon the purpose, depending upon the purpose of the, depending upon the purpose, control systems are classified as position control system, position control system, velocity control system, process control system, temperature control system, traffic control system, etc. So we are having various types of control systems depending upon the need. So these are the basic information regarding control systems.